I had a moment this morning where I talked about cranial sutures in space and how it affects the movements, midlines. What you don't realize in outer space, we have amazing movements that go through our bodies. We're thinking of range of motion, hand up, hand down, flexion, inflection, all of this, right? You have to start looking at the key factors. There's cranial buoyancy or skeletal buoyancy. Buoyancy goes to an all-time high in outer space because it needs to be paired with rotation. So rotational responses, I can't get up off the bed without rotation. We are not linear. I will not, in a million years, I'm going to float up and go in a straight line and stand up. It's not how the body works. So a lot of people think that we don't go back to infant development. It's not that we go back to infant development. That's who we are. We learned how to roll over. We learned how to get out of bed. It's the same movement. That's getting out of a car. And we need gravity. But we don't use gravity like a book where we're succumbing to gravity. We actually can oppose gravity. We do so with skeletal buoyancy, we do so with rotation, and we play with gravity, we organize with gravity in opposition to it, using all these factors. Now in space, it's not there. One of the things you can look at to see all of this, I have a simple, not totally inflated, but pool noodle, where I'm just using it underneath my atlas. Now just think of something as simple as the bone. The atlas is the bone, right? It articulates from skull movements into spinal movements. When someone has special needs, has any kind of movement disorders, when they have an atlas jammed, they are in chronic. They're in chronic because they have to now back arch or move their whole spine around this, where the atlas allows this nice counter. This is one of the biggest breakdowns you see with astronauts returning to Earth and why they don't have spatial orientation in space, and they don't have spatial orientation with balance and counterbalance when they come back from space. So one of the things that you're looking at here is just to learn movement functions, because we need these in robotics, we need this in artificial intelligence. If you don't understand these movements, you're not going to get the math that you're looking for gazillion calculations, right? And that's why I set up my AI system differently, because I needed the math, I needed these calculations, because that's what I do. So now you just got attention on the atlas here. I don't want you to think about muscle movements, I want you to think about what it takes to just look to the side. Now most people are going to yank their head and look over and do something like this, right? But if you've noticed in outer space, there's no peripheral vision. Right? For an astronaut to see you, they now, because there's no opposition to gravity, that means there's no midline setups. So I need to float around like this and now somehow find you and do this. This is one of the reasons why they break down with a sense of space-based autism, because they lose all their visual midlines. But they lose the separation of the head with the spine, right? And it becomes one unit. So again, it's breaking down their system in a sense to becoming special needs. The clients that I work with predominantly here on Earth, and this is the problem, because the spine is meant to be separate. But unless I'm tethered to something in outer space, I can't make these movements, right? And so just to appreciate it and get the calculations that are needed. Now these are exercises that you can translate into outer space, but again, first you have to understand the significance. And what's the significance? Because there's breakdown. When there's breakdown, this is also one of the key reasons why there's no reflexes in outer space. So now just again, think of now with what it takes to work with your vision to bring it over. Right, the pool noodle will help you with that weight transfer. It'll help you with that we're not here to oppose gravity, but just to feel these kind of movements. But this isn't about going left. This is about the dynamics of what it takes and through the atlas. So now again, lightly push through the feet, right? But don't push yourself off the table, because that's what happens in outer space. Just one little motion for the feet, I'm shooting across the can. Right, but right now for me to do this, how is this regulated? What kind of force in my body? Through the atlas, through all your body, but the atlas is key. If I put too much force, we complain about that. Oh, I slept wrong, my neck. And, we're pretty sensitive creatures when we don't do things right. And now just feel, too, what it takes to sink down and how, again, that atlas or that part of your neck regulates. Now when you're doing this, pushing through the feet, look down a little bit and feel what it takes to move up. Now again, a downward lower lumbar, a lower quadrant vision in space, right, doesn't exist. Now I have to actually start to, float this way. What happens? My eyes stay the same. My eyes can't do this and this in outer space. It can't cross midline in outer space because there's no opposition to gravity and there's no rotational movement in outer space. All of that leaves. And this is what you can start doing and seeing again all of the significance and movements as I start to rotate, weight transfer, and work on skeletal buoyancy using my atlas. I can look down and look up, and you can really see how this transfers that information through your body, the way that it counters and moves. All of these movements cannot be done in outer space. These are the things that we need to implement in outer space so astronauts can perform what they need to do, have the health that they need to do, less muscle atrophy, which is the big one there, and be able to work on the moon and Mars and do the missions that they're meant to do with these simple movements that are just not in outer space. But we need to look at it, calculate it, work with it, enhance it, stimulate it, and all of that in outer space as well as here on Earth. Thanks.